In this video, we're going to discuss electron configurations and the Aufbau diagram. To begin, let's look at a model of the atom. This is the model we typically see for an atom, and the electrons are found on the energy levels, and the energy levels are modeled as circles around the nucleus, but it's more complex than that. For example, there are parts called S, P, D, and F, and we draw them like we see on the right on the screen. And when we add them all together, we get something similar to this, but it can get more complex than this. And this would be extremely difficult to do and draw every time. So we write our atom like this, and we represent energy levels as circles. But there's more to the story when we talk about these electrons. And we're going to look at the Aufbau diagram and electron configurations for different elements and what this looks like. So let's start with the electron configuration rules. There are three that we need to look at: the Offbroad Principle, the Pauli Exclusion Principle, and the Hund's Rule. To begin, there's the Offbroad Principle, and it states electrons occupy the orbitals of the lowest energy first. Up on the board, you see an electron configuration and the Aufbau diagram. And this Aufbau diagram shows hydrogen. Hydrogen has one electron, and each electron on an Aufbau diagram is represented by an arrow. Well, Aufbau principle states that electrons occupy the orbitals of the lowest energy first. So what we do is 1s is the lowest energy, so we had to put an arrow in the 1s. We can't start at the 4s or higher, or we can't start somewhere in between. We have to start at the 1s when we start filling in our electrons. Now let's take a look at the Pauli exclusion principle. The Pauli exclusion principle states that only two electrons can occupy one orbital at a time. And if two electrons are occupying one orbital, they must have opposite spins, meaning the arrows have to be going the opposite direction. For example, let's say we're looking at helium. Helium has two electrons. We put it in the 1s, and we have two arrows, and the arrows are going the opposite directions. I can't put two arrows going the same direction, and I can't put more than two arrows in the same spot. Now let's look at the Hund's rule. The Hund's rule states that one electron must fill each orbital first before they share an orbital. For example, let's say you have 8 electrons to account for in your Aufbau diagram. Well, you put 2 in the 1s, 2 in the 2s, but now you have 4 electrons to account for, and each box represents an orbital. Well, what we're going to do is we put one arrow in the first box, one arrow in the second box, one arrow in the third box. Well, we still have one more electron, so we put the arrow opposite in the first box. We cannot put an arrow up one spot before filling in the 2p, and that third box is empty in the 2p. We can't do that. We need to make sure that you put one arrow in each box before you go back and backfill. For example, you can't do the following because the third box in the 2p does not have an arrow in it. You need to make sure every box has one arrow in it pointing in the same direction before you go back and backfill your second arrow in each box. Now let's go ahead and look at the periodic table, and there's 4 sections we need to look at: the S, the P, the D, and the F. When we look at the periodic table and we look at our electron configurations, we need to read it like a book, meaning you start with 1s, then you go to 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p. So you read it from left to right and top to bottom. Let's take a look at the periodic table, and we're going to look at the first few elements on the periodic table and how we write the Aufbau diagram and the electron configuration for these elements. First, let's look at hydrogen. Hydrogen has one electron. So we put one arrow in 1s. And then for the electron configuration, we have 1s with a 1 as a superscript. So 1s1 is hydrogen for an electron configuration. Now helium. Helium has 2 electrons. So we put 2 arrows in the 1s going the opposite direction. And then our electron configuration is 1s2. And when we look back, we can see helium would be in the top right-hand corner. And we see that would be a 1s and has 2 electrons, so 1s2. Now let's look at lithium. Lithium has 3 electrons. So we put 2 arrows in the 1s we have one arrow we need to account for still, or one electron, so we put that in the 2s. And our electron configuration is 1s2, 2s1. Well, let's look at beryllium. Beryllium has 4 electrons, so we have 2 arrows in the 1s and 2 arrows in the 2s. And our electron configuration is 1s2, 2s2. Now let's look at boron. Boron has 5 electrons, so we need to have 5 arrows in the Aufbau diagram. So we have 2 in the 1s, 2 in the 2s, and then we start filling in the 2p. And we have 1 electron to account for still, so we have 1 arrow. And our electron configuration is 1s2, 2s2, 2p1. And lastly, let's look at carbon. Carbon has 6 electrons. So we put 2 arrows in 1s, 2 arrows in 2s, and then in 2p, we fill in the first box with 1 arrow, and then we put the second arrow in the second box. You cannot put 2 arrows in that first box until you fill in each of the other boxes. And then the electron configuration is 1s2, 2s2, 2p2.